All right, so let's talk about the sign table. This says the critical values of a function are the values of x for which the function becomes 0 or infinity. The critical values of a function are the values of x for which the function becomes 0 or infinity. Critical values of a function f of x can be found by solving f of x is equal to 0. Now, if the function is of the form p of x over q of x, critical values of f of x are found by solving p of x is equal to 0 and q of x is equal to 0. Take these values, these values are also called the zeros of the function. So we're learning about critical values, and then we're going to then use what? The idea of the critical values in the sign and sign tables in order to solve inequalities. So let's start off with example 4. Example 4 is asking us to find the critical value of f of x is equal to 2x plus 1 over x minus 1. Now, in the literature that we just read, it says if the function is of the form p of x over q of x, the critical values of f of x are found by solving p of x is equal to 0 and q of x is equal to 0. In other words, if your function is a rational fraction, you would put the numerator equal to 0 and solve for x, and put the denominator equal to 0 and solve for x in order to obtain the critical values. So the critical values we're going to put the numerator, which is 2x plus 1 is equal to 0. So x would be equal to minus a half. That would be our critical value. We're going to put x minus 1 is equal to 0. So x is equal to 1 is a critical value. So the critical values are x is equal to minus a half and x is equal to 1. All right. Now let us look at how we're going to use the idea of the critical value and the sign table to solve inequalities. Example 5. Example 5 says, find the set of values of x satisfying x squared minus 5x plus 4 is less than 0. Well, the first thing I'm going to do is I'm going to obtain the critical values. Now, the critical values are the values of x for which the function is equal to 0. So let's factorize. We have x here, 4 and 1, minus and minus. So x minus 1 is equal to 0, or x minus 4 is equal to 0. X is equal to 1, or x is equal to 4 are the critical values. All right, so what the critical values sort of do is you're going to use the critical values to sort of like divide up your number line. So imagine this is as a number line. Your critical values are 1 and what? 4. So the critical values sort of divide up your number line into areas. So this is inside here is where it's sort of like your x-axis. This is where x is what? Greater than what? 4. In here, x is less than 4, but greater than 1. And over here, x is less than 1. So your critical values sort of like divide up your number line like that. Then now I'm going to draw a sine table. So my sine table, I'm going to have my values of x. So I have what? The region where x is less than 1, where x is what? Where x is less than 4 but greater than 1, and where x is greater than 4. All right, this is a sine table. All right, so next I'm gonna have what? X minus 1. I'm going to have x minus 4. And I'm going to have f of x, which is x minus 1 multiplied by x minus 4. So that's this. All right. All right. And what I want, let's examine now. Let us say what happens when x is less than 1. If x is less than 1, x could be 0. If x is less than 1, x could be 0. Now, if x is 0, x minus 1 would be negative. I'll say that again. If x is 0, x minus 1 would be negative, because it's going to be 0 minus 1, and 0 minus 1 is minus 1. So if x is less than 1, for example, if x is 0, x minus 1 would be negative. If x is less than 1, for example, if x is less than 1, for example, if x is 0, x minus 4 would also be negative. So x minus 4 is negative. X minus 1 is negative. A negative and a negative would be positive. So x minus 1 is a region on your graph where f of x is what? Positive. Now, let us say what happens when x is less than 4 but greater than 1. If x is less than 4 but greater than 1, x could be like 2. It's between 4 and 1. Less than 4 but greater than 1. X could be 2. If x is 2, x minus 1 would be 1, which is positive. If x is 2, x minus 4 would be 2 minus 4, which is minus 2, which is negative. A positive times a negative is equal to a negative. So for values of x between 1 and 4, f of x is negative. Now let us see what happens when x is greater than 4. When x is greater than 4, for example, if x is 5, 5x minus 1 would be 5 minus 1, which is what? Positive. If x is 5, x minus 4 would be 5 minus 4, which is also what? Positive. And a positive times a positive is a positive. Now, what I want is a solution for x squared minus 5x plus 4 is less than 0. In other words, I want the values of x for which x squared minus 4x plus 4 is negative. If it's less than 0, I want the values of x that makes that negative. And from our sine table, our solution is x is less than 4 but greater than 1, are the values of x for which x minus 1 multiplied by x minus 4 is negative or less than 0. And x minus 4 multiplied by x minus 1 is the same as saying x squared minus 4x plus 1. Those are the values of x. X is less than 4 but greater than 1 are the values of x for which x squared minus 5x plus 4 is less than 0. All right, example 6. Example 6 says solve the inequality 12x squared minus 5x minus 2 is equal to 0. So I'm going to solve this inequality using the sign table method. So if I'm going to use the sign table method, the first thing I need to do is to obtain my critical values. Now the critical values are the values of x for which 12x squared minus 5x minus 2 is greater than 0. Sorry, is equal to 0. So I have 12x. Sorry. All right, let's see if we can factorize this. Definitely going to have 2 here and 1. 4 and 3 for 12. So I have 4x here, 3x. This should be minus and this plus. So let's see if this works. 12x squared minus 8x plus 3x, then minus 2. It does work. Is equal to 0. So 4x plus 1 is equal to 0, or 3x minus 2 is equal to 0. So x, as a matter of fact, for these type of values of x, like x is equal to minus a quarter, or x is equal to 2 over 3. All right, those are my critical values. Drawing now my sign tables. All right, over here I have the values of x, starting with x is less than minus a quarter. In the middle, x is less than 2/3, but greater than minus a quarter. And finally, x is greater than 2/3. I have 4x, sorry. I have 4x plus 1. I have 3x minus 2. And I have the product, which is 4x plus 1 multiplied by 3x minus 2, which is essentially that. All right. It's just a factorized version of 12x squared minus 5x minus 2. All right, so when x is less than minus a quarter, so if x is less than minus a quarter, x could be like minus 1. Now, if x is minus 1, 4x plus 1 is going to be negative. If x is less than minus 1, 4x plus 1 is going to be negative. If x is less than minus a quarter, for example, if x is minus 1, 4x minus 1 would be negative. And of course, 3x minus 2 would also be negative. A negative times a negative is a positive. If x is less than 2/3 but greater than minus a half, so somewhere between 2/3 and minus a half is 0. So for example, if x is 0, 4x plus 1 would be positive. 3x minus 2 would be negative. A positive times a negative would make over here negative. If x is greater than 2/3, for example, if x is positive 1, 4x plus 1 would be positive. 3x minus 2 would also be positive. And a positive times a positive is a positive. Now, what we want are the values of x for which 12x squared minus 5x minus 2, which essentially is this, is positive, and 4x plus 1 multiplied by 3x minus 2, which is the same thing as that, is positive when x is what? Less than minus a quarter, and x is greater than 2/3. So to write the answer, you'd write the answer like this. The solution is all x such that x is what? Less than a quarter, minus a quarter. Then minus a quarter. Union all x such that x is greater than 2/3. All right. So it's something like that. They wrote the answers. Let me try and write it properly. These are the values of x for which 12x minus 5x minus 2 is greater than 0, which means the values of x for which it is positive. And our solution, according to the timetable, according to the sign table, is all x such that x is less than minus a quarter. Union all x such that x is greater than 2/3 are the values of x for which 12x minus 5x minus 2 is greater than 0. All right, so we have our answer. There's a little slight error here, so we can correct it. It must be minus a quarter. X is greater than minus a quarter. All right, example 7. Example 7 says, find the range of values of x for which x squared plus 2x minus 3 is greater than 12. Sorry. All right, let's make one side of the inequality 0. It's greater than or equal to 0. Positive 12 on the right comes over to the left and become negative. All right, then x squared plus 2x minus 15 is greater than or equal to 0. Let's get the critical values. All right, so the critical values are the values of x for which x squared plus 2x minus 15 is equal to 0. Let's factorize in order to solve this quadratic equation. So I'm guessing 5 and 3. This is plus and this is minus. So x minus 3 is equal to 5. or x plus 5, sorry, this should be 0, is equal to 0. So x is equal to 3 or x is equal to minus 5. Let's draw up our sign table. Where values of x, where x is what? Less than minus 5. Where x is less than 3, sorry. Where x is less than 3 but greater than minus 5, and where x is greater than 5. We have x minus 3. We have x plus 5. And we have f of x, which is our 2x plus, sorry, x squared plus 2x minus 5, which is the same as saying x minus 3 multiplied by x plus 5. Now, if x is less than minus 5, for example, if x is minus 6, x minus 3 would be negative. If x is minus 6, x plus 5 would also be negative. And negative times a negative is a positive. If x is less than 3 but greater than 5, for example, if x is, let us say, 0, if x is 0, x minus 3 would be negative, and x plus 5 would be positive, and negative times a positive is a negative. If x is greater than 5, for example, if x is 6, x minus 3 would be positive, and x plus 5 would also be positive, and the product x minus 3 times x plus 5 would also be positive. And what we want are values of x for which it is greater than or equal to 0. So the values of x for which something is greater than or equal to 0 are the values of x for which the thing is positive. So based on our sign table, our solution to x squared plus 2x minus 3 is greater than or equal to 12, which is the same as saying x squared plus 2x minus 15 is greater than or equal to 0. Our solution is all x such that x is less than or equal to minus 5. Union x, all x such that x is greater than or equal to, all right, I have 5 here, but it should have been 3. So let us see if that threw off the analysis. No, it doesn't. If x is greater than 3, this should have been greater than 3. If x is greater than 3, like if x is 4, 4 minus 3 would be positive, and 4 plus 5 would also be positive. So if there was an error, but even the error would still end up being correct, and this is greater than or equal to 3. So x is less than or equal to minus 5, and x is greater than or equal to 3 are the values of x for which x squared plus 2x minus 3 is greater than or equal to 12.